Hello, everyone, and welcome back. Before we begin here today, please like and subscribe because it really does help out our channel. So today we'll be talking about, and we'll be going over a problem of trigonometry, converting degrees into radians. So before we begin, just a quick tutorial here. So this will be my best attempt to draw a circle. Not bad. So when we're looking at a circle, you may know that there are 360 degrees in a circle. And radians is just another way to measure angles. So inside of a circle, in radian form, we have 2 pi. So every 2 pi of radians equal 360 degrees. So if we set up an equation here to correlate these two together, if we have degrees is equal to radians, which just to let you know, the abbreviation for radians is rad, we would have 360 degrees is equal to 2 pi. So if we just divide each side by 2, we would end up with 180 degrees is equal to pi. And this is the relationship in which you use to convert from degrees to radians or from radians to degrees. Now, if we are going from radians from degrees to radians, we would use this relationship of pi over 180 degrees to go from degrees to radians. Now, if you're going from radians to degrees, you would flip this, which we do have a video covering this. So let's go ahead and let's determine these values here shown on the screen, these three here. So starting with the first one, we have 120 degrees. So we're going to multiply that by pi over 180 degrees. And if you want to look at this in unit form, what you have is you have degrees times radians over degrees. So you would have degrees divided by degrees, and then you're left with radians. So that's a good way to remember the ratio of pi over 180, and then vice versa if you're going from radians to degrees. So we would have 120 degrees times pi over 180 degrees. So 120 divided by 180 gives me 2/3 of pi. And you could leave it as that, because a lot of times when you're dealing with radians as your angle measurements, you would leave it in some form of pi. And as I said, the RAD is just the abbreviation for radians. It's like the unit. Like this little degree symbol up here is the unit for degrees. RAD is the unit for radians. And if you were required to give the actual number, 2/3 times pi is 209 radians, which these two are equal to one another. All right, so let's move on to the second one, which is 30 degrees. Give ourselves a little bit more room here. So 30 degrees, and then once again, we're just going to take it and multiply by pi over 180 degrees to turn it into radian form. So we have 30 degrees times pi over 180 degrees, which 30 divided by 180 gives us 1/6 times pi, which is now in radian form, or you could write it as pi over 6 radians. Or if you want it in decimal form, like the real physical number, 0.524 is what you get when you take pi divided by 6. And all those values are equal to each other. The last one we have is a large value of 720 degrees. So it doesn't matter what the degree value is, if it's small or large, converting into radians, done exactly the same way. We're going to multiply by pi over 180 degrees. So we have 720 times pi divided by 180 degrees. So 720 divided by 180 gives us exactly 4, and then the pi is left over, radians. And then once again, if you need the actual number with decimals, 4 times pi gives you 3, or actually 39.48 radians. And either one of these answers is acceptable. As I said, most of the time when you're dealing with radians, you want to leave it in terms of pi. And that's how you convert from degrees into radians. Just remember the ratio of pi over 180 from degrees to radians. So I hope you found this helpful. If you want to see more problems of this varieties, please check out other videos on our channel. Thank you for watching, and I hope you have a great day.